Okay, good afternoon. And we're here at the Radisson, the BNA Radisson in Tennessee. That is the Radisson Nashville, Tennessee Airport. And as usual, as we enter into a new city, we introduce our amazing 5x12 matrix. This is a new city or a new state. And so let's introduce the amazing 5x12 matrix and its multi-dimensional applications. This already is getting dull. Let's try another. All right, so we project our amazing 5x12 matrix in the general form, and then we're going to project it in the electronics form, and also the pharmaceuticals form, pharmaceutical configuration. And you notice this morning we utilized the matrix in the pharmaceutical configuration to produce IPC series 1 to 168 illuminated polygon chemistry. But here we have it, we're coming back to our economics and the conditional infinity output of this amazing 5x12 matrix. So let's get into it and put up the general form first. So we have now A, B, C, D, E, F, G, H, I, J, K, L, 1, 2, 3, 4, and M, N, O. And we have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, ST. We do it like that because we always work in pairs. A, B, C, D, E, F, they are pairs. U, V, double X, Y, Z, and we start off with Greeks now, alpha, beta, gamma, delta. Let's use now theta, omega, zeta, rho, delta, and del, and omega, and pi. So here we have now, and usually this one takes some E star, rather B star, E star, H, K, N. So here we have our general form. I would say that the characteristic and property of our matrix is that after we have put it through the PDM or the DM processing, we have conditional to infinity output with monetary serials conditional to infinity, and that's how we have the economic application at the Mint. And we also had circuit analysis by the breakdown components of the matrices. For each 4x4, we have a 4x4 mesh circuit. We have 3x3 mesh circuit and 2x2 mesh circuit. Anyhow, so this is a general form, and we're going to do a lot of abridgment here because we have been doing this for the past 8 years. So if you weren't with us, then we'll be a little bit behind. So let's get it into the electrical electronics configuration. And so for the electrical electronics configuration now, we're going to say AB, C, D, E, F, G, H, I, J, K, L, M, N, O. And we say no, R11, R12, where the R's now stand for resistances. And we're going to do a little thing different from what we did over there in Las Vegas. We'll just have purely R's, resistances. We're going to introduce the other elements in circuitry, like conductance and capacitance. And so we have now, this is an RLC circuit. So we'll have now like L, R11, R12, L, 13, L, 14. C for capacitance now, C, 15, C, 16, and we come back to R. It's an RLC circuit. R, 17, R, 18, and that will complete 11. And down here now we have R21, R22, L, 23, L, 24, C, 25, C, 26, and R27, R28. And so the next one here now we'll have resistance 3.1, resistance 3.2, inductance 3.3, inductance 3.4, capacitance, C for capacitance now, 3.5, and capacitance 3.6. And we come back to know resistance 3.7 and resistance 3.8. The subscript usually say row 1 and column 1 and so on. Column 2, row 1. Column 3, R31 would be rows and column. Third row and the first column. So the next one here will be now resistance 4.1, resistance 4.2, inductance 4.3, inductance 4.4, capacitance 4.5, capacitance 4.6, and resistance 4.7, resistance 4.8. I don't know why, but my markers are running out. So I'm going to have here, let's see, this one. This is black. And for the last one, we have resistance 5.1, resistance 5.2, inductance 5.3, inductance 5.4, capacitance 5.5, capacitance 5.6, and resistance 5.7, resistance 5.8. Here we have now general form of for 5x11, 5x12, 11 matrix in the electrical electronics configuration. And for that, notice we use resistance, inductance, and capacitance, and resistance. And these are just the rows and columns, the 1.1 and the 2.1 and the 3.1 and the 4.1 and the 5.1. This is column 1, row 5, column 1, row 4, and so on. This will be R5.3 would be the 5 row and the 1/3 column. But we're working in pairs, so we'll be taking them like so. Pairs. So there we have our electrical electronics configuration. And what we're going to do, we're going to take a break. We've projected the general one, and we've projected this. And this is usually for the economics configuration. And we say now that this one has conditional to infinity output, exponential output, conditional to infinity output. And for this one, we'll be solving circuit analysis problem by the mesh analysis method. So we're going to take a break, and we're going to return to our amazing 5x12 matrix here at the Radisson in Nashville, or near the Tenessee International Airport. And this is number 418. That's just a marker for the room number. So let's take a break, and we'll return with our amazing 5x12 matrix.